Hello, my name is Angel Sunyan. I would like to share with you my experiences, which I hope will help you in your daily work. For this purpose, I prepared 4 videos. In this video, we will look at the transient response of different processes and their degree of difficulty. So far, we have considered the static characteristic of the processes which are valid in steady-state conditions. But what is the dynamic before the steady state occurs? The dynamic of the process is determined by the transient response of individual components of the process. So the transient response of the process output is response to the step change at the input with the control loop open. Due to the properties of some components to store energy, it takes some time for the output variable to reach its final value. We will look at the most common processes in heating, ventilation, and domestic hot water preparation. Here we see temperature control process with the mixing valve. With the step change in the stroke of the valve, we observe the temperature at the outlet. Response obtained at the output shows a transient response to the step function. And there is a so-called balancing time, which is defined as a time it takes for the process output to reach 63% of the final value. Because the process has one element of storage, we say that this is a first-order process. If the sensor is far from the valve, a delay time Td appears. Within that time, nothing happens at the output. In closed loop system, this means as if the feedback loop is broken. Here is a process of domestic hot water preparation, and it has 2 storage components, heat exchanger and sensor. Heat exchanger is presented as first-order storage element with delay. Therefore, process is second order with delay. And air conditioning process with channel temperature control is presented here, and process has 2 elements of storage, heat exchanger and sensor. And another process in air conditioning, which is room temperature control, and in return channel, and has three elements of storage, heat exchanger, room, and sensor. Degree of difficulty of the process. So if we want to compare difficulties of particular processes, then we need to find transient response which will be unification of all processes. So we need to make some kind of reduction in a common transient response. And it is mentioned in literature that this is a model of first order system with delay. And how to find in first order system with delay, we need balancing time and delay time. And how can we find these 2 parameters in any kind of response? We use so-called tangent method to obtain parameters for first order plus time delay model. A tangent is drawn at the point of inflection to get delay and balancing time. And therefore, and this is the way how do we get this first order system with delay and necessary parameters. So we introduce the degree of difficulty S in the process given by the ratio between dead time and balancing time. Now it is possible, because now we have only one type of transient response. This response first order system with delay. So, and if this ratio or difficulty, degree of difficulty S is lower than 0.1, then it is very easy control process. And if it is higher than 0.3, then it is difficult to be controlled. And here we have a list of different kinds of processes, and we see that some processes stand out in terms of difficulty. First one with the mixing valve, with the very where the sensor is far away from the valve, and there is also a process of domestic hot water preparation, and two processes in air conditioning, temperature control on return channel and in flow channel. How to reduce degree of difficulty and improve performance of control system. First of all, to choose a sensor with the shortest possible balancing time, and install it as close as possible to the valve, or even in heat exchanger in domestic hot water preparation process. And use pressure independent valves, which eliminates pressure disturbances and ensure proper valve authority. Also by using fast enough actuators. In our case, actuators are not included in processes. And the use of cascade and feed-forward control. Let us have a look in these two types of control strategy. How to increase performance of our control system. Cascade control is one solution. We get it by introducing additional measuring point, in our case T1, in that way that we split the process in two parts. And then we introduce also the additional controller, which is usually P-type, and we get two loops, inner loop or nested loop, sometimes called, and outer loop. And this is the way how to improve performance of process with high degree of difficulty. And there is also another way how to improve the performance of the system. It is feed-forward control. The basic concept is to measure disturbance and take corrective actions before they upset the process. In practice, in air conditioning processes like this, we introduce additional temperature measurement in the channel. It is T2, and additional controller, which is usually P-type, and we have we have inner loop with P controller, and this controller is with very high gain or with a very low proportional band, and input as a reference to this controller is the output from PI controller, which completely eliminates an error on controlled parameter, which is T3 in our case. So we see the difference in step response when we have only one loop, which is used only with one measuring point on a return channel, and in the case we have a cascade control with additional measuring point and with additional controller with additional inner loop. So we see a great difference between these two responses. And in the same way, we can use it cascade control in district heating substations, where is a very high deviations of pressures, fluctuation of pressures and temperature, and maybe also some other disturbances, and we eliminate them by this cascade control. Feed-forward control. We have here a process of domestic hot water preparation, instantaneous hot water preparation, and mechanical peak controller. And the system works in that way. The pressure drop on secondary side on the well V3 depends on the flow on secondary side. It means depends on consumption. And if the consumption increase, for example, then the pressure drop on this well increase, and this pressure increases is transmit on the primary side and open the valve on primary side V2, and therefore react on disturbance before the controller can sense or detect that there was a drop in temperature. So we have a proactive operation of controller. We can realize this algorithm, feedward controller algorithm, also with electronic controller, and we have flow measurement on secondary side, which detect the changes in consumption, and then give this information to the controller. But there, in controller, there has to be a certain model or algorithm what to do in the case of changing of consumption. It is increasing or decreasing, and it needs to be specified what to do. Thank you for watching, and I'm looking forward to meet you in next video.